Hello all, my name is Chirag Patil and welcome back to my YouTube channel. So in today's video, we will understand a gradient descent. Okay. So in previous video, we derived the logistic loss for the logistic regression, right? And our task is to minimize our logistic loss, right? So in machine learning, gradient descent used to optimize optimization problem. So it will optimize our loss function or find the best value for our loss function or minimize the loss function, right? So let's understand what is gradient descent. So first thing we need to understand is derivative or differentiation. Okay. So what is the differentiation? Right. So you had learned that thing like differentiation can be written as like this, right? dy by dx. Right. But what does it mean? It says how much our y will change according to x change, right? So we can write this as like rate of change in y with respect to x, because we are deriving it for x, like divide by dy by dx, right? So let's understand it from the geometric point of view. Okay, so let's say I have this function and I plotted this, right? Let's say y is equal to something function of that x, right? If you see, it would be like any parabola, like y is equal to x square or something, right? But let's understand from this graph. So let's say I have one point here, right? And let's say second point is here, right? So x change from here to here. Now how much y change? If I say y is changed this much, right? And x change this much. Okay. So this is basically y1 minus y2, which can be written as delta y, right? And this is x1 minus x2, let's say delta x, right? So this much this change, but if you see, this is making one right angle triangle right here. So let me draw that triangle from here to here, right? This line will intercept here and make some angle here as well, right? So let's say this triangle for this theta, right? Here we have the theta. So that theta could be, it's also like making the angle with this x line, right? So it could be like tan theta is equal to dy by dx, right? Tan theta is basically this side divided by this side, right? And this is our hypotenuse. Okay. So if we see dy by dx, it also can be written as dy by dx, as we see the rate of change in y with respect to x. But here, for this larger step, it could not look like an exact right angle triangle, right, to apply this geometry. But if there is very little difference between x1 and x2, right, let's say very small difference, right, 0.0 something, right, 0.002, let's say, right? So this triangle will be very small and you will get perfect triangle, right? Then we can apply this tan theta equation as well. So I can write, let me erase and write here, right? That dy by dx, right, limit x tends to 0 is equal to tan theta, right? When x is very small, near to 0, let's say we are taking very small step on the x side and then calculating the how much y is changing, right? So it could be written as tan theta, right? So now let's see what is tan theta. Okay, and what are the values tan theta can have. Okay, so if I go to next slide, so this is the graph of tan theta. Okay, so here you can see if tan theta or any let me write it this way, if theta is less than 90 and greater than 0, the value would be positive, right? Here we can see from 0 to 90 tan theta is increasing, right? For theta value 0 to 90, tan theta value will be positive. Same, if we say theta is greater than 90 and less than 180, it would be negative. Here we can see, right? Let's say we will get negative value. For theta is equal to 90, it is not defined, or we can say it is infinite, right? It depends. If it is minus 90, it would be negative infinite, and if it is 90, it would be positive infinite, right? So for 90, it is not defined, we can say, or infinite, right? So this is the characteristic of tan theta, right? So if we see in previous graph, right? So this part, let me put it this way, this part will have theta less than 90 and greater than 0, right? And this part will have theta, this is greater than 90, right? This angle, if you draw a tangent at any point, let's say this point, you will find this kind of tangent, this is making more than 90 angle with our x-axis, right? In this direction or from this side, we will have theta right. So if we get value or differentiation from this side, we will have negative value, here we will receive positive value, right? So this is the concept of differentiation and tangent here, which we will use in the gradient descent. Okay, so let's move further. This tan theta is clear, right? So now let's move further again from this graph. Okay, so now let's understand the gradient descent. Okay, so first we need to understand what we have to optimize, right? So we need to optimize our loss function or minimize our loss function, right? In logistic regression, we saw that our loss function is equal to log of 1 plus e raised to minus yi into w transpose xi, right? This was our loss function in the logistic regression, or it also known as a logistic loss, right? So here we had seen that yi and xi is our training data set, right? We have to just find optimal w which can minimize this loss, right? So here there would be summation I is equal to 1 to n, okay, for n data points. So this is what we have to minimize, right? So here we are not using dy by dx, but we will use dl by dw, right? Because we need to find best w which can minimize this loss function. Okay, so this will be basically like how much loss will change according to the w, right? Okay, so it makes sense. Let's understand how gradient descent is working. Okay, let me erase this as well. Okay. So in gradient descent, we will start from some initial weights, right? So we had clear we have to optimize w, so we need to start from somewhere, right? Let's say I had initialized one w is equal to, let's say, w0. It is initialized very well, right? Let's say initialized. Okay, so now how we will find the next w which will minimize the loss? So gradient descent is basically iterative algorithm in which we will improve the w or change the w according to our gradient descent algorithm and find the best w which is minimizing our loss. Okay, So now what will be our new W? Let's say W1 is equal to W0 minus eta times dl by dw at W0. Okay, with we will put the value W0 at there. Okay, so this will be our new W, right? Same, I'll explain what is happening here. Just understand the equation currently. W2 will be W1 minus eta times dl by dw with respect to W, and what at the W is equal to W1 right here. So I can rewrite this in general terms. It will be W new is equal to W old minus eta times dl by dw at W old. Okay, it makes sense, right? Okay, so we'll see what is the eta. Let's see. So let me say like eta is also known as the learning rate or step function or step size, right? So let me write it here. Eta is equal to learning rate. We will understand what eta can be has a value. So we basically eta will have positive values. We'll understand the impact of that. So now let's see here. I am using same graph. Let's say this is my loss functions graph, and at below we have the W, right? So let's say I initialize the value and I get this value of the loss, right? So if I draw a tangent at this point, right? Let's say I need to find the equation, not the equation but theta or the derivative, right? In this direction we will get theta we'll get theta, right? Let me rewrite. Theta will be greater than 0 and less than 90, right? If I get this value, right, at this point, my theta will be greater than 90 and less than 180, right? So here I will get negative value, here I will get positive value, right? Okay, so if we see the equation carefully, what we are doing, let's say initialize W is here W0, right? First of all, W old will be your W0, which we had initialized, right? Let's say any random number we had initialized our vector. So if I get this value with W0, then I will get any positive number here, right? If I will calculate the differentiation with respect to W and we'll put the W old value there, so we will get some positive value, right? And what we are doing, we are minus or removing some part or subtracting, right? So we are subtracting some value from the W old, right? Let's say here are the W's or W vector, right? So if here we have and we are subtracting something from the W, so we are going in this direction, right? So ultimately W will be contain lesser value than the W old, which we want, right? Ultimately we are multiplying with W's our training points, and then we are getting this value and we receive the loss, right? So we have to reduce the W's value, nice. So if we are minus or subtracting here something, then we will get lesser value for the W. Same, if let's say I am reached here, right? Then what kind of value we will receive? We will receive negative value, right? So if we receive any negative value here, so negative will become plus, and we are adding something into W, right? So we have to move in this direction, right? So we are adding something into W, so W will be contain the larger value than the W old, right? So if we are starting from this direction, we have to move towards this, and if we are in this direction, we have to move towards this, because we have to reach here, right? The best value. So if in this case the best value is 0 for the loss function, so we need to find the W where the loss is near to 0, right? So I hope this equation is clear for you, right? Why we are using negative sign here, like W old minus eta time dl by W dW, right? So now let's understand this eta, right? So let me erase this thing first here so we can understand better. I'll just write here, so we will get positive value here and we will get negative value in this direction, right? Okay, so let's say we had started from this. Okay, let's I started from this and I get some value. Okay, so we receive some positive value and going in this direction. Okay, and the step function step value or learning rate, let me call it learning rate. Okay, so eta is the learning rate. Learning rate would be have positive smaller value. Generally people take eta is equal to 0.01 or 0.001. Okay, this kind of value will eta has like, or 0.1 as well. It's a hyperparameter, I would say, or it sometimes people fix it like eta will be used for 0.01 for whole training, and it can be changed over the training, right? Okay, so I'm moving into this direction, right? So let's say when we are here, we will take larger step here because the tangent would be higher, right? So here, if you see that theta would be lesser, right? So we will get some lesser value. So we are moving a smaller step here, right? And somehow from here, I reached here, right? And for the next step, when I performing this operation, right? Somehow I moved from here to here, right? So now I have to move to this direction using this function. But if my learning rate is too high, right? Let's say I am using larger learning rate. Let's say it is like 1 or 2 something, right? So I will move from here to here and then here from here, right? Because we are getting the direction and we are getting the values. So I will come this side at first iteration. When I will update the weight, I will reach at this time, this side, right? But I have to reach here. So when we are having lesser loss value, we have to use smaller learning rate, right? So that's why sometimes people use adaptive learning rate, which can be changed according to the iteration we are performing, or according to the loss value, right? So this is basically control how much our step, how much we will take a step to update our old weights, right? So if you are putting like larger value, let's say 100, so this will be very smaller value. You are subtracting some larger value from our original weight, right? So we have to find best learning rate, and generally it is very smaller value like 0.1, 0.001, that kind of thing. Okay. Okay, so let me erase this as well. Okay, so we are doing this thing, and when we will stop, we can stop either by finite number of steps, right? So we are doing like, let's say we initialize W0, then we receive W1 is equal to W0 minus eta time dl by dw. Then I receive W2 is equal to W1 minus eta times dl by dw. So we are so on and so on. And if we reach like, let's say 100 step, right, we will stop this training. Or if our loss value is very small, let's say we are getting loss value like 0.01, then we can stop. Or the third point, if from previous point to next step, let's say I have updated W1 and W2 and I am not getting significant difference in the loss, right? So let's say let me write it here. Let's say when I was at W1, right, I get loss like 0. Let's say 0.05, and when the W2 I get loss 0.04, and W3 I get 0.03. But now if I get W4, it would be 0.029, right? For W5 it would be 0.0289, something like this, right? So here you can see my loss is not decreasing, right? So that means we are very near to our global minima. This is also called as a global minima, right? In this whole function there is one only minimum value, which is 0 here, right? So we are near to our global minima, or we are reached to our global minima. Hence, let's stop the training here, right? Right. So this is all about the gradient descent, how it is working, right? So dl by dw will be the differentiation of our loss function, and we'll calculate the value by putting our x and y, and then accordingly we will update our weight. Okay, so this is all about the gradient descent. If you have any question, you can write it down in comment section and we can discuss there, right?